All right. Thank you, everyone. My name is Mike Bush, and I am serving as the coordinator for the WSDA Apple Maggot Survey. This is my sixth year. Um, there are over 40 years a history with this Apple Maggot Survey. So I'm a relative newcomer. But before I worked as a coordinator for WSDA, I had worked as a Yakima County Horticultural Pest and Disease Board coordinator. And before that, I retired from WSU Extension over in Yakima. So, what I want to talk about today is what we did in 2025 and what we are planning to do in 2026 for the Apple Maggot Survey. To start off, just a little bit about the apple maggot and why we're concerned about it. Of course, apple maggot indicates that it is an immature fly. No one really cares about the immature fly or the fly itself. What is really catching people's attention is the damage it can cause to the apple fruit itself. It's important to note here that this fly is invasive to the Pacific Northwest. It originated from eastern seaboard states here in the U.S., and it is very important to say that to date, this damage has never been intercepted in apples from any commercial orchard in eastern Washington. And that really is what we are shooting to maintain. The objectives of the apple maggot survey are threefold, and one is to determine the pest-free areas of Washington State for apple production. And the reason that that's important is that producers in the pest-free areas can transport fruit throughout Washington State and to any overseas markets that wants it without going through an inspection process. Meanwhile, we also have quarantined areas in the states, and Washington State Apple Maggot Survey will conduct certification around those orchards in the quarantine areas of the state. And that again is to try to reduce or eliminate, I guess is the better word, that any fruit that might be infested with apple maggot is not moved within the state. The third objective is to monitor waste facilities for green material that might be a potential mode for apple maggot to move from one area to the next area. Monitoring for apple maggot is really based on monitoring for the apple maggot fly. And that's because we would prefer to have the flies do the moving and traveling and do all the work to find our yellow sticky traps that they find to be very attractive. The yellow color is what's attractive. We make this trap even more attractive by adding a carbonate lure to these traps. And you can't really see it on that, but if you imagine if you put your hand on that yellow sticky trap in the upper right corner, it is sticky, and it's that sticky substance that will capture the apple maggot flies. We hang these traps on host plants only, and those host plants are apples, crab apples, and hawthorn, and we'll be hanging those in rural, farrow, and backyard host plants. So rarely and never do we put these in the orchards themselves. Our goal is to intercept the apple maggot before it gets into those orchards. So these apple maggot traps will be going out in mid-June, and they will stay out hanging until the end of October. Typically, the first fly, apple maggot fly, is captured in early to mid-July. In 2025, it was on the later side. We actually caught our first one on the 24th of July. The flight activity for the fly will actually peak in mid to late August, and we will have some fly activity that draws out through the month of September. Fortunately for us, this coincides with the student workforce that we recruit from universities around Washington State. Um, and so that is the season in which we spend our time trying to monitor the presence of apple maggot and determine the distribution of apple maggot in Washington State. All right. Every year we shoot to get at least 5,000 yellow sticky traps deployed out in eastern Washington. Often we will strategically place those yellow stick traps within half a mile of a commercial orchard and at a rate of at least one sticky trap per square mile of areas that produce apples. We place those yellow sticky traps usually in easily accessible places like coast trees along roadsides, residential areas, right of ways. And each of those traps that we place out must be checked every 2 to 3 weeks for the presence of apple maggot flies. If there is a suspect fly on that yellow sticky trap, the trapper will replace that trap and immediately bring the sticky trap with the suspect flies into the lab for confirmation or species ID of the taphritid fly on that trap. Seems pretty easy, except we do have a number of flies that look very similar to the apple maggot. As you can see, the apple maggot is on the picture on the very extreme left, and next to that is a picture of the snowberry maggot fly. This looks almost identical to the apple maggot. I can tell the difference between the two because I think that the fly in the second image is actually got short and stubby wings compared to the apple maggot. Um, but that is not always a reliable trait. The other insects or taphritid flies that we find that may be confused with apple maggot include the western cherry fruit fly. And if you look at that third photo, you'll see a little claw at the end of the wing. That is very distinctive, the western cherry fruit fly. And another fly that we catch a considerable number of is the walnut husk fly that we not only is the banding on the wings different, but the overall body color is different. Anyway, the toughest part about this is these flies are pretty small, only a eighth to 3/8 of an inch long in total. Okay, as I had said, when our trappers catch a suspect fly, they will bring that back to the lab immediately. And so you'll look at the box of yellow sticky traps back, and you'll notice that there are probably hundreds, if not thousands, of flies caught on that yellow sticky trap surface. We will have a crew in the lab that will go and look at these traps grid by grid, looking for any taphritid fly, identifying them, immediately entering that data on a database, an online database. And then if they find any fly that looks like it is a snowberry or an snowberry maggot fly or an apple maggot fly, they will need to take those and put them under a microscope where they will look to see if they are males or females. And if they're males, they can examine the underside of that abdomen to look at that strange little structure to see if it's twisted and curved and divergent or convergent. So this one is a little bit bent and convergent. If it's a female fly, they actually have to dissect out the ovipositor and measure the length of that ovipositor. As a rule of thumb, if that ovipositor is greater than 1 millimeter in size, it's an apple maggot. If it's less than that, it is a snowberry maggot fly. So this is where we spend a lot of time trying to make sure that the fly that we identify or confirm as apple maggot is done properly. All right, so in 2025, we had over 5,000 traps out in the field. We put those traps in about 16 different eastern Washington counties. And most of our, if you look at the scattering of dots on this figure, you'll see that most of our traps are actually centered or strategically placed in areas where apple production is ongoing. There are a number of different surveys that we do, and I'm not going to go into that other than saying that the response that we have to a positive trap count is a little bit different for every one of the positive finds that we have. Most of our traps are in the non-quarantine or what we call the pest-free areas. And those response, if we catch an apple maggot in those areas in the green, which is the pest free, is we immediately go back out to the site and we start the limiting, putting more traps out to try to pinpoint the host that or the source of the apple maggot population. But you'll notice that there are also traps in the quarantine areas, and that's by request of the growers. And that is in case they want to move their fruit from an area that is quarantined to an area that's pest free. We have to show that there is no apple maggot that is caught within half a mile of a commercial orchard, or that the apples from that orchard have to be inspected by the Fruit and Vegetable Inspection Service. This year, a little different, I should say in 2025, something a little different that happened is we actually went and put some traps out here in this very eastern side or corner of Klickitat County. And that was in response to a shipper that wants to move fruit. And so those traps that we put out were placed there to make sure that no apple maggot was caught within half a mile of the commercial orchard that wanted to move the fruit from Klickitat to either Yakima or Benton County. So in 2025, like I said, we made our goal of putting out 5,000 yellow sticky traps in host sites. And then we put those out in 16 counties. And in all those, we had come up with 258 apple maggot flies, which, relatively speaking, compared to the 46,000 taffridid flies we caught, seems small, but that does create quite a bit of work for us. Like I said, there were a lot of taffridid flies out there, that 46,000, and of that, only 8,300 were actually suspect flies, which we had to determine whether they were snowberry maggot flies or apple maggot flies. And snowberry maggot flies, they don't have anything to do with apples. They are more interested in those little white snowberries and feeding on those. So, any rate, 258 of those flies were determined to be apple maggot, and they are from very few counties, Chelan, Kittitas, Okanagan, and Walla Walla counties. So just to give you an example what our response is when we catch something, here is a look at Columbia and Walla Walla locations. Way back in 2023, we actually caught some apple maggots in Columbia County. We investigated that. We put out more traps in that area. And one of the things that we determined is there really is not a commercial apple production area in Columbia County. Although there are some apples grown, they are not shipped outside the local area. And nevertheless, you could see that our response is right across the highway in Walla Walla County. We made sure we increased the number of traps there just to intercept anything that may be coming across the border. Now, we didn't just leave Columbia County alone. We actually got some collaboration, cooperation from the Washington Parks and Rec, and they had hired a contractor who went out and sprayed the host plants where the apple maggots were found. So we have had someone treating those areas for the past 2 years, and we have not caught any more apple maggots in that area. So this is a feather in our cap, and in another year, if we don't catch anything, we may go back to a very sparse trapping of apple maggot in that county. But meanwhile, in Walla Walla County, despite all the traps we have out there, we did have a positive trap. And in response, we increased the trapping area, our trapping density, and we have nearly pinpointed the source of apple maggot in that area. And in 2026, we do intend to work with the new county pest board coordinator to respond and to somehow try to eradicate or contain apple maggot in those areas. Okay, now I know why I put that in. So hot from the press, there is some legislative motion going on there to increase the quarantined area of Okanagan County. Our hopes is that it will capture a lot of these things here in red. These are positive apple maggot catches, and really expanding the quarantine area is kind of despite all efforts, valiant efforts by the pest boards to contain apple maggot in those areas. We know that it is a far cry for us to try to remove the apple maggot infestation in the riparian areas that hold some of the native hosts like hawthorns in that area. And so our defense here is really helping the growers, increasing grower awareness and doing what we can to keep apple maggot from getting into those orchards, and an attempt to keep apple maggot or infested apples from being removed from that new quarantined area. So the 2026, I'll show you a different map that will have a different area quarantined. In that, I know that many years ago we started this series of meeting conferences with the idea of inside looking out. And that is one of the things that we will probably end up pushing very hard in Okanagan County, because the defense, a defendable border, is actually the orchards themselves. And by getting a producer awareness there and taking measures to intercept any invasive apple maggot into their orchard. We have hopes of maintaining the apple maggot survey program for and movement of apples out for another 40 years. Any rate, in 2026, even though the quarantine area will be expanded, there will be no change in our monitoring or our inspection activities in that area. So I think that's one of the more extreme cases of what happens when we have apple maggots that we are having difficulties controlling. Is we will try to expand that quarantine area to keep apple maggot from spreading to our most profitable and invaluable resource of pest-free apples from Washington State. All right, a couple more slides. One of the things that I learned the past few years is a lot of international trade partners are very interested in, or maybe concerned about our response to any apple maggot confirmations that we have in our program. And I can say as soon as we find an apple maggot on one of those traps, we immediately contact the horticultural pest and disease boards at the county level. And we notify them and give them the exact location where each positive site has been found in their counties. We also immediately contact the F&V inspectors and notify them of the location of each positive trap catch. And that is because these are the responses. These are the agencies that create some of the responses to help maintain and guarantee our trade partners there's no apple maggot in the crops, in the apples we send them. This process has become automated. And so as soon as a person in the lab confirms that an apple maggot is there, that notice will be sent directly to the pest boards and the inspection, F&V inspection. And as for the apple maggot survey, what we do is in a pest-free area, we will immediately increase the number of apple maggot traps or within half a mile of any apple maggot find. The other response is, of course, WSDA Fruit Vegetable Program, and they will, in turn, on a report of an apple maggot find, initiate an inspection process by contacting any apple grower within half a mile of that positive apple maggot trap site. Now, the grower, once they're contacted, if that grower wants or wishes to move their fruit, they will need to have their orchard inspected, or they need to put their fruit in storage on a certain storage regime for 30 days. F&V does like to go out and make an in-field inspection. And so they will try to do that within a couple weeks prior to the harvest. All right, and like I said, pest boards are an important component to our response. And as soon as we notify pest boards, they will contact, if it's a residential area, they will contact that person and homeowner and try to manage it. Then we have a number of strategies we use. The first strategy is tree removal. That's the best one. The next one that we'll use, if someone is really not happy about us removing that tree, we will remove the fruit for 3 years. And then the third one is spray treatments. And if you look at the top, this is a right of way, and you can see a yellow sticky trap in there where we had an apple maggot find. and that hawthorn is now seen better days and has been taken care of. The other photo is actually a contractor out spraying a homeowner's apple trees in an effort to eradicate any apple maggot that may be infesting the fruit in those trees. All right, so how am I doing on time, folks?
I think
You can have really 5 minutes, so then you have time for questions, but
All right.
yeah.
Okay, well, this is going to be the last slide, so I'm doing okay. Some of the things that we want to do in our program for 2026 is we are pretty proud of the mapping that we've inherited from our prior administration and maintained by our local intelligence department. And so we know that some of the pest boards have been using it, but we're going to encourage them even to use these mapping even more in 2026. Um, this mapping program will show any of the coordinators exactly where all our host sites are and where all our positive apple maggot finds are. I mean, right to the tree in which those finds were made. Um, so by hopefully cooperating and interacting with the pest boards, the response can be even faster in getting to the host sites and taking care of it. As a mutual benefit, last year was not our most profitable apple year for sure. And so there may be a lot more abandoned or removed or non-viable commercial orchards that are susceptible not only to invasive apple maggots, but we are anticipating a tough year with coddling moth. And you'll get to hear a little bit more about that in the next talk. And so we're hoping that by helping the horticultural pest and disease boards, we can better meet the objectives of the program, the survey program itself. The other thing, and Josh will be involved, Josh Milnes will be involved in this a little bit. Work that he has done has kind of indicated that there may be a preference of apple maggot to certain hawthorn species. And so we're going to look a little harder, train our trappers to be able to identify the hawthorn species that they're putting in and see if there is really an association of apple maggot with hawthorn plant species. All right. So, yes, I'm open for questions if we have time, and if we don't, well, I'll give you some more really cool jokes.
Awesome, thanks. So if you can post your questions in the Q&A or raise your hand, we'll unmute you. There is a question here for you, Mike, from Jeff. What is the best treatment schedule for apple maggot infestations, and maybe what chemicals?
Well, that is a question that you'll have to direct towards your local Washington State University Extension Service. They will have the best and legal recommendations, both for commercial producers, and they can help homeowners as well, especially since they do have a master gardener program that will help with residential areas.
Thanks, Mike. Just looking through and making sure I'm not missing anyone with their hands raised. And I'm not seeing any questions in the chat box. There's a question here. Mike, do you know if Eastern Washington is still accepting yard waste from Western Washington for compost? Because most has apple maggot.
We are looking at that pathway and making sure that that is not a pathway through which the apple maggot can take advantage of and move from west side to east side. We actually do put traps out around some of the areas that accept waste from the other side of the mountains. And those waste sites do have to register with Washington State Department of Ag. So we are very aware of that possibility and on top of it.
Thank you. I have another one here for you. Thoughts on SIR or on a apple maggot? Is that feasible?
So the sterile insect release. I know that WSU and other agencies are working on research on that, but I don't know how encouraging that is, how practical it is. But I know people are looking at trying to work it out.
Thanks. What is the most prominent source of apple maggot in these natural areas? Hawthorns, crab, apples, anything?
We were looking at our data from 2025, trying to get a feel for that. And right now, it seems like a hawthorn is a likely source because, well, commercial orchardists are on top of the apples. So we are looking at hawthorns, and that is why we're actually looking at hawthorn species to see if the apple may has a preference for one species over another. But right now, the source is hawthorns, and in Okanagan, it was the hawthorns in the riparian areas that the growers and the responses could not get to.
Thanks. You'll notice in the chat box that Danny, who's actually our next presenter, went ahead and posted two different links for you. One is a link to a backyard fruit tree spray schedule, and the other one is an apple maggot control options. And both of those are publications available from WSU's Tree Fruit Extension.
Thank you, Danny.
Yeah. Other than
Happy to
that,
be
just
here.
some.
Cassie, why don't we get the code word up for folks?
Yeah, so the code word's actually going to be after the next presentation. So Danny, if you want to go ahead and get your slides up. And then I have a little introduction here for Danny. She works at the Washington State University as an extension educator for tree fruit and integrated pest management. One of her major focuses is to provide quality outreach and extension resources to the extremely diverse tree fruit industry that is prominent in Washington agriculture. I know that she really loves her job. She does a great job with it. Her love shows through her work. And she handles other issues too, like coddling moth, identifying diseases in trees, helping researchers in their field trials, and scouting for aphids, mealybugs, releasing biological control agents, or sometimes random missions on Thursdays to rehome a wandering swarm of honeybees. Danny is a wealth of knowledge, and we are excited to have her. So go ahead and take it away. You are on mute.
That'd be helpful. So thank you for the introduction. So yeah, I'm here today to talk to you guys about coddling moth and management. So I think the first thing whenever I think of coddling moth, I think of the quintessential worm in the apple, which is coddling moth. Coddling moth is kind of the apple worm that you are most often going to encounter, which hopefully nowadays you aren't finding any of those in the grocery stores. And if you are, we have some issues, so you should contact me. So coddling, to give a little background, coddling moth is an invasive species, but from the way that we've been talking about invasive species during this seminar today, it's a little different in that coddling moth became an invasive species before, the USDA or the WSDA ever existed. So we didn't have these great programs like we have for apple maggot or spotted lanternfly, where we were able to quarantine and stop the spread of these. So coddling moth is a really great example of what can happen to an industry that fails to contain or to suppress a invasive species. This species of moth is originally from kind of this area in the Middle East, Asia Minor, where coincidentally also apples are native to. And as of now, it's present in every major apple growing region in the country, except kind of Japan has managed to keep it out somehow. And in Washington specifically, it's been here for over 200 years. I think the earliest accounts of it in the United States were in the 1700s. So this pest is extremely well established, but still very invasive. So the scientific name for this pest is Cydia palmanella, and it is in the family Tortricidae, or the tortricid moths, which are a group of moths that are very notorious for being pests of agricultural crops. So things like the oriental fruit moth, the lesser appleworm, the light brown apple moth, all of your leaf rollers, these all kind of fall under the same category. So this is a group of moths that are very, very detrimental to agriculture. And when we're trying to identify our adults, they're usually about 1/2 inch long. They have these alternating grayish brown banding on their wings. But the real easy way to identify them from other moths is these characteristic bronze scales that they have on the tips of their wings. And then also, like other tortricid moths, they have these, they keep their wings kind of in this tent formation whenever they are at rest. But the most important stage of the coddling moth is obviously the larval stage, which is where we are getting our fruit damage. So the larvae has 5 instars, but we typically only ever see the first instar or the 5th instar because the rest of those instars are very well protected within the apple once they are into the fruit. When they're newly hatched, they have this characteristical black head and a small creamy white body. And then when they're mature, they get a brown to black head capsule, and that creamy white body kind of turns slightly pink. But this is actually kind of typical for most tortricid moths. So coddling moth is considered a direct pest, which means that it causes damage to the fruit directly by things like feeding. And the stage that is responsible for this, like I said, is the larval stage. And these damages will manifest in things like stings, which are shallow entries where they just kind of nibbled on the fruit, or you get these really deep entries where they have finally, permeated and started working their way through the fruit. And then a characteristic of coddling moth that is a little different from other moths that I'll talk about in a little bit is that it tunnels directly to the seed. So it needs the proteins that are inside of the seeds to develop. So very often, and pretty much always, you will see that they will go very directly straight to the seed. And coddling moth is an oliphagus pest, so it mainly feeds on rosaceous hosts. Unfortunately, Washington has quite a few rosaceous hosts, so it has lots of options, but it's mainly going to be feeding on apples and pears. But some minor hosts that are of note are things like hawthorns, crab apples, and ornamental pears can be a big problem, especially as wild sources for populations. Quince, walnuts can be a huge issue in California. Plums, apricots, and some peach and nectarine infestations have been reported. So I just want to generally go through the life cycle with you briefly. So obviously we'll start with our adult that I showed you earlier. And then these adults will go on to lay eggs, and the eggs are typically oval and flat and laid singly along fruit or leaf surfaces. And then as the egg develops, they will get this very characteristic red ring, signaling that they're getting close to hatching. And then we have this stage called the blackhead stage, where you can see the head of the larvae start to develop, and they'll hatch out, tunnel into the fruit pretty immediately after hatching from the egg, go through their larval development stages, and then eventually they will exit the fruit and find a spot within the tree or the leaf litter to spin up a cocoon. and then they will either overwinter, so they will stay cocooned until the following season, or they will immediately go on to pupate and then become the second generation in the cycle. And then we can have up to 3 generations per season. 3 generations is very typical for our growers now, and a lot of them are starting to see a 4th generation. So this pest just continues to become more and more difficult to manage. So a quick note for things that aren't coddling moth. So another pest that we have in this area is a pest called oriental fruit moth, or OFM. OFM is typically a pest of our stone fruits, whereas coddling moth is typically a pest of our pome fruits. But OFM will also quite often be found in apples, and it has become a growing issue in apples in recent years. So I'm trying to focus a lot on growers to make sure that they're making this distinction and identification because it's important for how we approach management. So quick differences: OFM will affect the twigs and shoots of your plants, whereas coddling moth will not. So if you're seeing damage like this, you can be pretty safe to say that it's OFM and not coddling moth. And then they have a difference in their behavioral pattern for whenever they enter the fruit. So coddling moth will go directly to the seed, as I mentioned, but OFM will kind of meander and go around the seed. It's not interested in the proteins in the seed like the coddling moth is. And then just because it's fun to talk about, coddling moth has no structure at the end of its abdomen, whereas OFM will have a structure called an anal comb that it used to kind of flick the poop off of out of its burrow. So it's a very quick and easy way to tell the difference between the larvae. So the most important things that we do for coddling moth is our modeling and monitoring efforts. So, like I said, going through the life cycle, here we have all of our life stages, but it's really difficult to observe all of these life stages directly in the orchard. But it is really critical to know when and where they are present. So we have to figure out a good way to do that. And luckily, the place we can start with this is that knowing that insects' development is very temperature dependent. So every insect has a threshold with which they start to develop, and then a threshold in which they will stop to develop, or they will stop developing. And using that information, we can accumulate these things that we call degree days, which is when the average temperature of the day is 1 degree above the developmental threshold. So coddling moth, for instance, has a developmental threshold on the lower end of 50 degrees and then higher end of 88 degrees. So what this means is that if we have a day where the average temperature is 51 degrees, we know that we have accumulated 1 coddling moth degree day. And it would be great if that was all we needed to do this, but because insect development is temperature dependent and temperature and environment can vary very heavily from site to site, it's not enough just to know what the degree days are just by counting average daily temperatures. So we do these things called phenology models, development is asynchronous as well. So we have overlapping generations of where we have eggs present, adults present, and larvae present. And then we also have, the end of one generation is the start of the next generation. So there are very few off days for growers because even one misspray can be quite catastrophic for future generations. And then this is also difficult because it quickens the rate at which we are developing resistance to our pesticides, because if you're doing good stewardship of pesticides, you want to switch your mode of action from generation to generation. But with that overlap, you are kind of exposing generations to some of the pesticide, even if you're trying your best not to. And then there's also no single treatment window. A lot of our pesticides are very stage specific. So we have ovicides, larvicides, but we don't have a lot of products that function as both. And then we don't have any pesticides that specifically target adults anymore. We used to when we had some harsher, more broad spectrum pesticides, but we're moving away from that. And then a majority of the larval stage is very heavily protected inside of the apple for most of its development. So you really only have between egg lay and entrance into the apple to make a difference on the coddling moth population. So models really help us make sure that we're targeting peaks of vulnerable life stages. And these models help us predict insect development using those degree days I explained. And then they also tell us what we can't see. So when we can't make direct observations, we can understand what's happening in the field anyway. This is a table that was put together that shows all of the degree days and the percent moth flight and the percent egg hatch that you can expect during those degree days. This is a lot of a chart to interpret, but basically using this information, we can know, okay, adult emergence is about 175 degree days. I know egg lay is going to be about 200 degree days. I know egg hatch starts at about 385 degree days. And having this information makes it very beneficial for how we target and utilize our pesticides and manage our pesticide spray programs. And another thing to keep in mind is that the timings of these aren't the same every year. So because temperature is variable, the rate in which we accumulate degree days shifts. So you can't just expect that I'm going to have, my sprays on by May 1st every year, because that's when I know the timings are. If you look at this chart I have here, this is from a program we have called the Decision Aid System that gives us degree day information. We can have a very large variation year to year on where we're at in degree days. So in 2023, for example, we were less than 140 on May 1st, but in 2025, we were beyond 240. So it's not enough to just know where you're at calendar-wise. You have to be paying attention specifically to their biology and development. But modeling alone isn't the greatest tool. So we really encourage a dual-pronged approach where you are using the models to understand what you can't see and using trap capture to kind of validate what's actually happening in your specific field. And we do that by using these orange or sometimes white triangular traps called delta traps. And then they have sticky cards inside of them that capture the moths. And we attract these moths using these little rubber stoppers that have species-specific pheromones. So these are typically, they're generally attracting male coddling moths, but we do have some lures and pheromones that will attract both male and female. For trap and monitoring, it's really important that we get the traps out before we have our adult flights. So I mentioned earlier when we were kind of expecting adult emergence. So it's really important that we get traps out before about 175, 100 degree days. And that it's also important where we're placing the trap within the canopy. If we're placing it too low, we know by backed up research and data that we've done that most moth activity as adults are happening up in the top of the canopy. So if we're having it down here, it's going to be less effective than if we're putting it more so kind of in their face. And then it's also important that we are focusing on where we're placing our traps within our orchard. Coddling moth, like most pests, is not uniformly distributed throughout an orchard. So if you only have one trap in this corner, you're missing all of this that's happening inside your orchard. So it's really critical that you have traps placed kind of throughout your orchard so that you can have as much information as you can when you need it. Because if you're missing the information that's happening here, this problem is going to get exponentially worse before you're aware of it, and it's going to start running away from you. And then the next thing we typically talk about is how do we interpret trap capture once we have it. It's not an easy science to kind of dissect that. So factors that influence trap capture are pretty much everything. But the important thing is that the most important thing that we focus on is typically temperature and weather. Especially in the first generation, we know that the temperature may be good enough for them to develop and progress through their life cycle, but it's not necessarily good enough for them to fly. So you will have development happening, but you won't have trap capture. And this is why we really recommend that you're doing both modeling and monitoring at the same time, because you need the information that both are giving you at the same time. Without it, you're kind of have an incomplete picture of what's happening in your orchard. And then to go through some management for coddling moth, go through the life cycle again. So the main tools we have for coddling moth are mating disruption during the adult stage, residual and topical ovicides during egg lay, larvicides during the vulnerable periods where larvae are outside of the apple. And then some cultural controls that we have are things like removing outside sources, which is a big one when it comes to backyard tree fruit. Removing damaged fruit so that we're stopping development as much as possible. And then also banding helps disrupt that life cycle and remove them from the orchard. So one of the most foundational pieces of our coddling moth management programs is mating disruption. And mating disruption works because insects rely on pheromone cues to find each other out in the orchard. And we know that The males will come in, they will find the females based on their cues. So we've been able to develop tools where we artificially recreate the pheromones, and we can use that to delay mating by confusing the male moths. So we bring them in, they're very persistent trying to find the females, and they will get trapped up by these dispensers. And this is a pretty cool video that was sent to me last year of kind of mating disruption in action. So you can see the moths floating around this dispenser that's right here, and they're looking and they're expanding resources and they're delaying mating. And this is just a still image of that. And this concept works because we know we have research that supports that the longer that it takes for a female to be mated, the less amount of eggs that she's going to be able to lay. So we're not killing any of the moths with this tactic, but we're significantly trying to reduce the population as we go along. And one of the key points that we always make about mating disruption is that more point sources are better for control of mating, and fewer point sources introduces things like variability, reduced efficacy. You have to make more management interventions, and you're going to see increased damage. So the rate at which we typically recommend or consider a full rate of mating disruption is 400 point sources per acre. And this is also kind of why, as much as we wished it did work, mating disruption doesn't typically work as a small acre or like backyard intervention method. So this is typically a large-scale orchard operation, that intervention. And this concept kind of works as like, here's a standard orchard planting. Here's my pheromone dispensers, my male moth down here, and then my female moths. If a male moth is entering the orchard, he's going to each of these dispensers. He's eventually going to get tired. He's eventually going to give up searching once he realizes a female isn't there. And he's going to keep searching, but can substantially delay the time it takes for him to find her. And when they did it at these rates, they were able to, they saw a 10%, saw 10% damage, but increasing those rates to around that 400 per acre, visually, you can see more dispensers, more disruption, more delay. And they increased these rates. They saw less than 4% damage with just that amount of increase. I'm going to skip through these ones. This is just a little bit of density dependency. And the mating disruption tools that we have passive dispensers, which are these rubbery tools that are infused with the pheromones. These are called hand applied or passive dispensers. And we typically recommended these at 400 per acre. And then we have also these active aerosol emitters, which I equate them to like the Febreze or like the Febreze fresheners that you would have in your house that kind of go off on a set period of time. These also are available as mating disruption tools, and it significantly reduces the amount you need per acre. So you only need about 1 dispenser per acre. And it's important also that you get these up around the same time that you are doing your trapping, because it is an adult-focused management tool. Mating disruption is also really important that we have it in the right part of the canopy as well. So this is too low to be as effective as we want it to, so we really need it to be up here where the activity of the moths is going to be happening. And then to get into some of the spray programs, I probably won't be able to get through all of this. This is a long talk. Coddling moth is a very complex pest. But if you need spray program recommendations, especially for orchard level pesticide products, the WSU Crop Protection Guide for tree fruits is available on our website and has a wealth of information. So the important thing about spray programs is that we first understand that coddling moth growth potential is kind of astronomical, generation to generation. So this was some data that Betsy Beers at WSU collected showing unmanaged coddling moth growth generation to generation. So, and 2 times, 5 times, 6 times, 9 times population growth that you're seeing just one generation to one generation, which is only a couple of weeks. So it's critically important that you are on time with your sprays and you are not missing any of them. And like I said, timing of your spray application is critical, especially because these windows are very narrow. So for example, eggs, we only have about 6 to 14 days from egg lay to egg hatch. For larvae, like I said, they enter fruit almost immediately after hatching, and most of our larvicides need to be consumed, so not just contact. So it's important that we're getting it on early enough that they are actually able to feed on it before entering the fruit. And like I said, they're protected very well within the fruit thereafter. This is the standard programs that WSU recommends for managing coddling moth, specifically with our trying to match it up with our apple stages and then our degree days after January 1st. This is the recommended degree days, and then this is the action that you do. So mating disruption, residual or topical ovicide. You don't do a residual and a topical. You either pick a residual or a topical. And then larvicides, and then going into our second generation, and then third generations. Spray coverage is critically important for management. If you are spraying, if you are paying money to spray a pesticide and it's not being effective, you are wasting money. And this is a good example of where we had enough coverage to get this egg covered, but not enough coverage to get this egg covered. So, and this is the difference of millimeters in distance to each other. And then also, this is an image that I found, or that a picture I took earlier last year, where we had, what looked like good coverage on the side of the apple that was facing the row in the sprayer. But if you turned the apple a little bit, you could see the decline in spray coverage and then the immediate entrance of a coddling moth as soon as that vulnerability is seen. And then we have a couple cultural controls that we also use and that are becoming more and more popular with how much more difficult coddling moth is becoming to manage, especially in organic operations. So we really hound on things like thinning and pruning, bin management, removal of fruit, banding, and netting. So thinning and pruning is pretty self-explanatory. The thinner your fruit is, the less opportunity there are for areas of missed coverage, and then areas where you're not actually able to see visible damage, so you're not aware of what's going on in the orchard. So thinning fruit, making sure you don't have these bundles and the apples aren't pressed up against each other. Pruning, especially for your pollinizers, like I mentioned earlier, crab apples and like things like that are great hosts for coddling moth, especially when you have pollinizers that are above your tree canopy. And your sprayer nozzles aren't calibrated to hit that far up in the tree. These are really great reservoirs where you will see tons and tons of coddling moth stings. Bin management is really important because larvae will get into our bins and then they will overwinter in them, and then they will come out next season when we put the bins back in the orchard, and especially late in the season. They give you more late season damage, especially when our monitoring efforts are slowed because we're focusing more on harvest. And they also develop at different rates, which can affect our spray timing and trapping data. And then sanitation, this is probably the most labor intensive of all of the management options, but if you are just leaving the fruit on the ground, the larvae are still going to be able to develop and exit the fruit afterwards. So it's really important that you are fully removing the larvae from the orchard, and you can do things like tilling or flailing it, but it's not good enough to assure that you have gotten all of the larvae in the apple. There's high chances that you're actually missing the larvae. And then cardboard banding is a management tool that we've been doing for a really long time, probably as long as coddling moth has been an agricultural pest, which is where you just set up these 3-inch corrugated strips of cardboard at the base of the trees, and then the idea is that when the coddling moth come down to pupate, they pupate here, and then you can remove these and remove it from the orchard. And the key timing for this is to do it in September if you're trying to do the last generation, and then remove kind of November to February. You have to remove it, otherwise you've just given them a hotel. And then you can do this in other generations at 1,000 and 2,000 degree days, but it's going to be most effective when most of the larvae are going to be overwintering at the end. And then I'm running over, I think. So removing sources is the last thing I want to talk about. It's really important that we look for sources outside of the orchard, and especially in backyard trees. These are huge sources of coddling moth for our commercial growers, especially. Even in Wenatchee this year, we had a volunteer group go around and divvy up acreages, and they found 170 just rogue trees out there that are sources of coddling moth damage. And then these tiny backyard trees are significant problems where we're getting multiple stings in these apples, and then once the population gets too big here and they're overwhelmed with each other, they're leaving and they're infiltrating our orchards. Which is a big focus of mine, is working with the pest and disease boards to try and get these homeowners educated on how to manage coddling moth and kind of the impact they're having on the industry. I already went through all that, but okay. These are also the tools. WSU's website has phenomenal resources to help manage coddling moth, and I'm happy to help with anything. So sorry for going over.
No, you are actually good. You're within time. If you have any questions for Danny, go ahead and post them in the Q&A. Raise your hand and we can unmute you. I saw a notification on the Q&A, but I'm not seeing anything new. So if I missed something, Carla, please catch it. There is a comment in the chat box. I apologize because I don't use I don't spray trees. Armart 30 DF made by Atticus LLC has an excellent knockdown property on adult coddling moth. Growers must hatch the PHI and MRL.
Yeah, that I am not aware of that study, but I would be if you have the information on that, I'd be more than happy to look into it.
Cool. So I'm going to go ahead then and share our next code word. A comment just came through, the best coddling moth talk I've ever heard.
Thank you. I apologize. I went through it a little fast. I was ambitious in the amount of slides that I could cover in 30 minutes.